All right, everybody, let's go ahead and get started. So for those of you who haven't met me yet, my name is Steve Mills. I'm a mechanical engineer at Facebook. I also am the co-lead for the Open Compute Rack and Power project that we're sitting in here today. So today I'm going to be talking about Facebook's V3 frame specification. So first of all, kind of let me describe what that is. So there is an Open Rack specification that's out there right now on the wiki. There's a generic one that we're currently at 2.1 that describes all the interfaces for generic Open Racks for everybody. Today I'm going to be talking specifically about the Facebook version of Open Rack. So Facebook is currently at V2 version of Open Rack architecture, and we're going to be shifting to Open Rack V3. So I'm going to just kind of do an overview of that today. So let's go through the goals for this particular project. So when we developed Open Rack V1, the community was relatively modest at that time. So there wasn't a whole lot of people to get feedback from. So for both V1 and V2, we kind of pushed the specs out to the community pretty far through the process of development. So for V3, our goal is to release these very, very early on in the process in an effort to get as much feedback from the community as possible. We would like to ideally incorporate features that are not necessarily specific to Facebook, but are needed by the community in an effort to kind of get as much of the community to be able to share this basic frame part number as much as we can across the entire community. So kind of to that end, we've already started sharing this specification. We initially started working with Microsoft to get feedback from them on what it would take to kind of make it easier for us to transition Open Rack into Microsoft's environment, and so now we'll be looking more to the community to kind of help with that as well. One of the other major initiatives for this is to kind of help integrate in all of the work that's going on in the Advanced Cooling Solutions sub-project within Open Rack. So if you guys have been involved in the workshops that are next door for advanced cooling, all the specifications that are being developed there will eventually get rolled into the architecture for V3. So there'll be some way of bridging all the innovative stuff that's going on there into this framework going forward. So there'll be a method of getting both the direct contact liquid cooling solutions as well as the door heat exchangers. So those will be going from ACS into Open Rack, and then the things that we're developing, say around bus bars and interconnect solutions, will be coming from the Open Rack project going into the immersion, which is the third work stream related to advanced cooling solution sub-projects. So what we're hoping to do is, by getting feedback early from the community and incorporating these features as well, we'll end up with kind of a single platform that'll be much easier to share across the OCP community. So let's go through some of the proposed differences between Facebook's Open Rack V2 and our V3 version. So first of all, we'll be increasing the dynamic load rating from the current 1,400 kilograms to 1,600 kilograms going forward. This will give us a little bit more weight to handle some of the rear door heat exchangers, which could be kind of heavy. We'll also be enabling two different heights. So currently we're at 2013, and 2210 currently for V2. We'll be incorporating both these two heights as well as we go forward. On the current version of Open Rack V2, the cable manager, as if you've seen any of the Open Racks that are out on the floor today, cable managers are integrated into the structure of the rack frame. So As we go forward, what we're going to be doing is taking the cable managers out of the structural frame and making those into a separate optional unit. So what that'll allow us to do is, if you have different configurations, depending upon whether you've got storage or optical cabling in the rack frame, you can develop different cable management strategies. And that also makes it a lot easier for end users outside of Facebook to also modify that same component and use it in a broader array of uses than just what Facebook's developed. So another thing that we heard related to V2 is that our side panels are really only intended to maintain airflow through the rack, but other users, particularly in a co-location situation, they need security as well. So we'll be able to enable both the security side panels as well as the airflow for Facebook. And we'll do the same thing related to doors. So doors weren't necessarily a feature that we needed when we started V2, but since then we've seen submissions by Nokia and others with a door associated with them. So we'll integrate those features for support of a door into the rack frame up front, which will enable not just EMI doors like we had from Nokia, but you can also do security doors for co-location, or you can get the heat exchanger doors from the Advanced Cooling Solutions group. So next is bus bar voltages. So again, when we started V1 and V2, we only had 12 volt as an option. Since then, 2 years ago, when working with Google, we integrated a 48 volt option for the bus bar into the generic OpenRack specification. So we will be also enabling both the 12 volt and the 48 volt in the OpenRack V3 frame for Facebook. What's kind of helped enable that is a contribution from Ratal, where they've taken the design of the bus bar and we've converted it into a kit. So the interfaces, both mechanical and electrical, and they're all the same. So now you can go out to suppliers of bus bars, and based on the specification, you can order bus bars with different voltages, with different power levels, and mix and match your particular customer's needs with the bus bars that are available out on the market. So it just makes the rack frame much more flexible than what we had when we started on V2. As Zoe alluded to, for V3, we'll be going from the 2 power zones that we've got right now, where we've got one at the top and one at the bottom. We'll be switching to that where it'll be just one complete power zone along the entire length of the rack. And we'll also be going to a universal AC whip interconnect. So unlike V2, we've got the regionalized interconnect that goes into the bus bar or busway, at least for Facebook. And then there'll be a single cord that runs down into the back of the power shelf. So we're hoping to standardize for that particular interconnect. So depending upon what region you go to, you'll still be able to use the same power shelf and the same interconnect. So this will allow us to do away with the PDUs that we currently use, and you'll be able to ship the same rack level configuration to any region of the world. If you come back, I believe at 4 o'clock, we've got Harding that's going to be presenting on that particular specification that they're working on for us. So that's going to help enable this particular feature for not just necessarily for Facebook, but hopefully for a wider portion of the community. So we can kind of look at some of the features I just talked about real quick. So this is kind of a rendering of what OpenRack V3 might look like. So these are the security doors. So again, these are different features that are not part of the main welded frame that gives the community the ability to kind of customize the variation of OpenRack that works well for them. So these are security doors. These could also be EMI doors as well, side panels, again, whether they're just for airflow or perhaps security for your co-location needs. And then the 12 volt or 48 volt bus bar, again, is a separate kit, easily modifiable now based on the work that we've been doing. And then the cable managers. So these cable managers, you can see in the kind of the purple plates that are there. I kind of go back and forth so you can see where they fit in open rack. So these plates can, like I was saying earlier, you can adjust the shapes of these. It allow you to move where you're clipping the cables in. It also allows you to, if you've got cabling that's going from rack to rack horizontally, you don't have to go up and back down again. We can cut holes in the sides of those and go straight from one rack into the other rack to minimize your cable length as speeds get higher. So it just provides a lot of flexibility for solutions that are at maybe coming up across the community. Let's look at, nope, not that button. That's not a good choice. There we go. So this is just a rendering of some of the work that's getting done in the advanced cooling solutions sub-project. So this is working on a front mount heat exchanger door. And we've also working on a rear-mounted heat exchanger door. So there's several versions of these based on the needs of the community. There might be several different implementations of what these doors are doing. So if any of these look interesting to you, you might want to check out the work that's getting done in that particular group. In terms of direct contact, liquid cooling. So this on the left-hand side, you can see the front-mounted manifold. So there's both a hot and a cold kind of buried up into where we would normally keep cables, data cables. So those are basically manual interconnects where you can connect the manifold directly to the IT gear, and then you need to service it. You just manually disconnect it, pull the IT gear out, put it back, put in the new IT gear, and then manually reconnect those. Those manifold sizes just happen to be the same as the ones that are in the back on the right-hand side. So this is the rear mount blind mate manifolds. So in this case, you would have your IT gear, you plug it in, it would pick up the power on the bus bar, blind mate, and you can also pick up the liquid cooling loop as well. So the particular zone that you see there for the rear mount blind mate manifold is, so we will be reserving that area in the main specification as an optional choice. So if you do choose to put in the manifold, right, it'll be predefined, you'll know exactly where it goes. But if you don't need the high power and liquid cooling loops, then you can continue to use that space like we're doing right now for fans, particularly around like storage implementations where you're not necessarily going to need that high power cooling loop, right? You can still use that volume for fans or something else that might come in handy for your particular need. But if you do choose to use it, then there's only going to be one way to go implement that. And then final thing I wanted to show you real quick was an optional rear pluggable network. So we will be, again, reserving some volumetric in the back, optionally, if you would like, where we can now plug the IT gear directly into a data backplane. So there's potentially 3 different options that you could use in that particular space. So you could have your high-speed copper, you can also have a high-speed optical interface, as well as perhaps a lower speed management bus, which, maybe that's just your health and telemetry information. I don't know if anybody has gone over to the Microsoft booth, but they're showing a similar version of that where they've got a management backplane in the back of OpenRack v2. So here's what we've got going on next. So as of right now, the specification that's covering all this work is now out on the Rack and Power Wiki, so you guys can go and download that. The next thing we're going to be doing is, once we get feedback from the community, we will be building prototypes of this particular infrastructure to be available later on this year. So what we need from this point from the community, right, is we're looking for feedback on features and details inside that specification. The goal of which is to, again, try and incorporate the needs from as broad a swath of the community as possible into the design up front. So this is where we really need the community to kind of get involved to tell us what needs to get incorporated into this now before we go too much further along down the path and it starts getting difficult to start doing that type of integration. So I'm going to show just some of the work that's going on right now. So there's quite a bit of components that are going to go into the development of this architecture. So there's a pretty good list. So as you can see, we're going to be busy in Rack and Power this year, developing specs for all this. Our ideal state, there we go, is that we'll have open sourced specifications for all these available towards the end of the year. Several of these we've already started working on. And as I mentioned several times, there's quite a bit of work going on right now in advanced cooling. We need those specifications to get finalized so we can start importing all that directly into OpenRack. So we'll have those available for tests later on this year. So if any of these particular areas look interesting to you, right, we come get in touch with either myself or with Caleb, and we'll get you involved in some of this work. So I realize this is just a very high overview of what's going on, just based on the limited amount of time that we've got. So I can take some questions right now if anybody's got some.
Yeah, looking at the way on the water-cooled version.
Yes.
When the water cooling's on the front, the cooling port's on the left-hand side of the equipment, and when the water cooling's on the back, the cooling's on the right-hand side of the equipment. Is it logically that way for a reason? Because I have no experience doing that, but I would tend to think, put the cooling on the right-hand side in every case.
Sure. So it's on the right-hand side. Because Microsoft has their PDU solution on the left-hand side in the back. So the manifold will be on the right-hand side in the back. So that makes sense. So whether it's on the front, it could be on either side. It doesn't matter. So that's just the way I happen to pick it. So yeah, and convenient enough, it could be on either side, right? Because now you can do it either way you like. So. Anybody else? Thank you for your question. That's good. Yeah.
Hi, Steve. Once
Hello.
Again. You many time say about Microsoft feedback. I think many people in that room so much interested why you frequently using that brand in case of the standard OCP rack. Please open a secret. You thinking about convergency, real convergency between Olympus story, Microsoft story, and OCP drive it by yourself? Or you not have that kind of ideas?
Well, what we're trying to do is make it easier, right? So you can share higher level components between all of OCP members, right? So by making sure that we can get, I don't know if you saw Brandon's presentation this morning at 8 o'clock, but Brandon from Microsoft was showing how they had essentially ported their equipment into OpenRack v2. So that kind of got us going, well, okay, well, what else would you need to make it better for an OpenRack v3, which is kind of what started the conversation with them. So they were just kind of our initial contact with the community on what kind of features do we need to incorporate into an OpenRack v3 to make things easier not necessarily just for Microsoft, but for everybody in general. So it's more, they just happen to be the first kind of early feedback that we got. So now we're making it public and trying to get more feedback from a larger group. But Microsoft will certainly be just one of one interested party. Does that kind of answer your question? Okay. Yeah, go ahead, Harding, or Will.
So you mentioned that the cable manager is optional, but the idea is that all the open racks will have cable managers. It's just not necessarily Facebook's cable manager.
Yes. I suspect that most people would use that. You conceivably could get rid of it entirely, right? If you went to a rear-mounted blind mate solution, then you might not have any cables up front. So it could be optional in that case. You might still want it for air control, but it's, yeah, to your point, right? It could be anything, and at least for the time being, you're probably going to see it up front. Trying to see. It's also handy. There might be some, like I mentioned, there might be some setups where you want the cables to run from, say, a central location to racks side by side, where you're very limited on the distance that you want to go, or maybe you've got a lot of density for, say, a switch deployment, where you've got a whole rack full of switches. Then that gives you the ability to kind of remove that and get it out of the way, which you can't do on V2, and then you can do quite a bit of cabling that way as well. So it just gives you a lot more flexibility in what you want to do. Thanks. Yes?
Hi, you mentioned you are moving from 2-zone power to 1. Is
Yes.
there any spec where the power shelf and battery shelf would sit? Would it be in the middle of the rack, or would be? I would ideally like to see them on the either on the top or bottom.
Top and bottom, okay.
Especially top, because the power cables would be out of the way.
Mm-hmm.
Is there any thought or spec on that?
Sure. So I didn't get a chance to go through much of the power architecture related to V3 yet. The plan right now, or one of the items that we have up here is a blind mate interconnect between the power shelf and the bus bar. So if we can get that developed, then essentially you could put the power shelf anywhere you want on the bus bar. So if you want to put it at the top or the bottom, you can do that flexibly based on whatever configuration you want. Unlike what we've got right now in the current generic 2.1 specification, where you have a bolted interconnect and you're kind of forced to put it in those particular locations. We're hoping that we can get to a point where you can have a pluggable solution that allows you to put it anywhere. But yeah, definitely putting it at the kind of the top certainly helps from a cabling standpoint, although the losses might be a little bit higher once you get up to some of the higher powers that we're talking about potentially in the next couple of years. So, anybody else? No? All right. Thanks a lot. Appreciate it.